This is a problem from one of your lab assignments in section 3.1. They want us to differentiate this function y equals 3x squared plus 5x plus 9, all that divided by the square root of x. Now this function is a quotient, and eventually there will be a quotient rule that we can use. But right now we want to see if we can do this problem without the quotient rule. For this, we're going to take a look at this function and realize that the numerator is a few terms that we're adding, and we have one term in the denominator. So we can actually break up this fraction into three different pieces because there's three different terms in the numerator. So the fraction will be broken down to 3x squared divided by x square root of x plus 5x divided by square root of x plus 9 divided by square root of x. And keeping in mind that square root of x is x to the 1/2, and our exponential properties, we're essentially subtracting the power in the numerator minus the power in the denominator, and we can combine our x's that way. So here we have x to the second power and the second power, and here we have x to the 1/2 power. So we want to perform the expression 2 minus 1/2. That's 2 minus 1/2. And so if we just find common denominators, we're going to get 3/2 for this. And that would be 4 over 2 minus 1 over 2. So we get 3/2. So that's what we'll put here. Similarly, we're going to do the same thing. 1 minus 1/2. And this is just a 1/2 in the denominator, so we can think about that as x to the negative 1/2 power. Or you can also think this is x to the 0 in the numerator being multiplied with a 9, and you have 0 minus 1/2. So we have simpler power functions that we can deal with where the powers are just fractions. So now that we have our quotient written as a sum of power functions, we're going to do our derivative. So we're going to use the power rule. The derivative of x to the n, where n is any real number, is equal to n. So the power goes down, and then we have x n minus 1 power. So the n minus 1, the n is subtracted from the power, so we're going to need to compute some n minus 1s. So our first term has x to the 3/2, so 3/2 minus 1, so that's 3 minus 2. It's going to be 1/2. And here we get negative 1/2. And then for the last one, we have minus minus, that's negative 3/2. So applying the power rule, these are going to be the new powers. And so for the first term, the derivative of this is we bring the 3/2 down and multiply by 3. So that's 3 times 3/2. So just to be clear, we're doing 3 times 3/2. So that would be 9/2. X to the 1/2 power, so that's the derivative of this first term, and now we bring the 1/2 down, so that's 5 times 1/2, and then the power is going to be x to the negative 1/2. So again, bring the power down, that's 5/2. 5 times 1/2 is 5/2, and then x to the 1/2 power, and then the last one, I'm sorry, x to the negative 1/2 power, because we had to subtract. And the last one will bring the power down. It'll be 9 times negative 1/2. So that's going to be a negative 9/2. And I notice that there's a plus here, so this has to be a negative. So that's a 9/2, and an x2, we take this power and subtract 1, we get negative 3/2, and that's what they got. Okay, so that's it. Now we can write all this out as is, or we can go back and apply the square root stuff. And so let's try putting the square roots back in there. So this is 9/2 times the square root of x plus 5/2. Now this is x to the negative 1/2, so I would probably go back down to the denominator and put the square root of x there. And then I have negative 9/2, and here is x to the negative 3rd. So we can put the square root of x to the 3rd power or whatever in the denominator, but we can also just write x. We should be able to just write x to the negative 3/2. So there are many forms for this particular answer. You can see what I had written over here and what the form that they were looking for. They're mathematically equivalent, so they should be able to take either answer. All right, so I hope that was helpful. Good luck.